A warm welcome to one and all to listening to this video. This video is all about the object-oriented programming principles. Um, Basically, the object-oriented programming is a methodology, okay, mainly used to develop a software applications, okay, based on objects. So objects are nothing but real-world entities, and these real-world object entities, whichever has a well-defined boundary or shape or structure, are called as objects. So why we go for object oriented programming? So object oriented programming is basically predecessor of structure oriented programming. So as we know, structure oriented programming uses definitions, define functions to perform a specific task. Okay, so as the program complexity increases, it is very difficult to provide abstraction, security, and flexibility to the data. So to provide the real life entities in programming approach, object oriented programming came into existence. So in real world object has two important characteristics. One is attributes and second one is behaviors. So attributes are nothing but the the physical properties of the objects are called as attributes, and the behavior which the object exhibits are called behaviors. So these are the examples of objects, a few examples of objects where we have each object has some properties and as well as it has some behaviors. And for these objects we are defining it as a class where the different instances are these examples. So these examples are the different instance for the class. So another object example for classes and objects. So we take a class called student where we have some set of attributes and set of behaviors. So attributes like name, age, color and sex, and behaviors eating, drinking and running. For this class we are declaring an object where we have three instances for the class objects. One is John, Sophia and Lily. Okay, for each of these objects a separate memory gets allocated once we declare object for the class student. Now coming to the important concept, object oriented programming principles. So there are four basic principles in object oriented programming. So which is why object oriented programming is most popular and widely used. The first principle is abstraction, second encapsulation, third is inheritance, and fourth is polymorphism. So first coming into abstraction. So basically in any object oriented programming the basics is classes and objects. So classes is nothing but any it's a prototype or it's a blueprint of an object, okay, where each object is going to have a set of attributes and it is going to have set of methods. In object oriented programming, these classes and objects form this basic of this four object oriented programming principles. So first one is abstraction. So abstraction is nothing but providing the necessary details to the user and hiding the unnecessary information is what is abstraction. Okay, when we go to an ATM machine, so the how the working of that or the implementation of your ATM is not necessary. We need to just, the user has to know how to operate with the ATM machine to withdraw money from his account. Okay, this concept is called as abstraction. In Java, abstraction is provided by abstract classes or it is provided through interfaces. Second important concept of object oriented programming is encapsulation. So because of these features of encapsulation, it provides security to your object oriented programming. So encapsulation is nothing but the binding of code as well as the data into a single unit is called as encapsulation. So we already know that each class will have a set of variables as well as a set of methods. So grouping them into a single class is what is called as encapsulation. So why the name encapsulation? Is similar to a capsule where the medicine is the data which you want to access and the capsule is nothing but the method to access those data. So similar to your capsules where the medicine will be present and outer capsule will carry the medicine. If you want to access the private variables which is not visible to the outside the classes, those variables can access using the methods. So this process is called as encapsulation. And why this name encapsulation? So third is inheritance. So deriving one class from another class is what we call it as inheritance. So where the derived class or the subclass will have all the properties and methods of the superclass or your base class. So for example, there is a superclass called as class from which all the properties and the methods are inherited. And the class which inherits, class bus, class car and class truck in this example inherits the properties and methods of your base class. So these class bus, car and truck are called as derived classes or subclasses or child class. So coming to the different types of inheritance, basically there are 4 types of inheritance: single, multi-level, hierarchical, hybrid inheritance, and last one is multiple inheritance. So single inheritance is deriving one class from another class is what I call it as single inheritance. And if the single inheritance is applied in multiple levels, then it is called as multi-level inheritance. So a class which has 2 or more classes which has the same base class is called as hierarchical inheritance, and hybrid inheritance is a combination of either single, multi-level or hierarchical inheritance. The 5th type of inheritance is multiple inheritance. If a class has more than one base class, then it is called as multiple inheritance, and Java does not support multiple inheritance. So the final concept of object-oriented programming is polymorphism. So poly means many. So they are performing different actions in different ways is what you call it as polymorphism. So there are 2 types of polymorphism. The polymorphism which happens during your compilation time is known as static polymorphism, static binding, early binding, or compile time polymorphism. The polymorphism which happens during your execution time is called as dynamic polymorphism, dynamic binding, late binding, or runtime polymorphism. In Java, static polymorphism is implemented through method overloading, and dynamic polymorphism is implemented through method overriding. So static polymorphism, if this happens during your compilation time, it is static polymorphism, and the approach which the static polymorphism implemented is called as method overloading. So method overloading is nothing but a method with the same name but having different types of variations in the parameter list is called as method overloading. So the variation in the parameter list can be the number of parameters, the data type of the parameters, the order of the parameters, and the return type of the parameter. So based on this variation in the parameter list, the different functions will be invoked based on the arguments we pass. In this example, we have 2 different functions. One is sum. Both the methods names are same. So sum and sum. Here 2 arguments in the first method sum, 2 arguments are passed and both the data types are integer. Whereas in the second method, the same data method name is sum, but instead of 2 arguments, in this method 3 arguments are passed. So during the invoking, depending upon how many number of arguments passed, it will invoke the corresponding method. So this happens during your compilation time. So depending upon how many arguments you pass, the corresponding method will be invoked, and this happens during your compilation time. That is why it is called as static polymorphism. Coming to dynamic polymorphism, it is implemented in Java with a concept called method overriding. So redefining the base class in the derived class, redefining the methods of your base class in the derived class is called as dynamic polymorphism, and this is achieved through method overriding. If you see here, the base class is dad, where we have a method called eat, and the boy is nothing but the derived class which extends your base class. So if the same method eat is overridden in this derived class, and you have different outputs. So during your compilation time, whosoever object is created, depending upon the object which is invoking the method, that particular method will be invoked. For example, the object created for this is the derived class. So when we create object, when we invoke object.eat, it invokes the method of the derived class. So during execution time, based on whose object is created, the corresponding method is being invoked. That is why it is known as dynamic polymorphism. So and this dynamic polymorphism is achieved through method overriding. Thank you.